and then we'll share my screen. All right, y'all, so this is 9B, and it's dealing with linear modeling. All right, so we'll be looking at linear functions. So a linear function has a constant rate of change, which is also known as the slope. So a constant rate of change known as the slope, and has a straight line graph. So it's a straight line graph. And that's actually what linear means, is a line, okay? So when you got a linear function, the slope or the rate of change, what that means is that for every unit you go along your dependent variable, the dependent variable goes up the same rate, or it goes down the same rate. Okay, so we'll look at that more when I start getting into the slope more. So, like I said here, the rate of change is the slope, actually. The greater the rate of change, then the steeper the slope. Okay, and what we're talking about, steeper the slope, is that slope's either going to make an uphill line, it can make a downhill line, or the slope could actually make a horizontal line. So we'll look at them and we'll see how these slope numbers are affecting that, okay? So to find the slope, we got a formula we use. So the rate of change, or the slope, is going to be equal to the change in the dependent variable that's divided by the change in the independent variable. Okay, so remember, the dependent variable is your y-axis. The independent variable runs along your x-axis. And that's where they get that rise over run from. So if I was going to actually use 2 points to find my slope, I would take the independent variable, so it's the second independent variable, minus the first independent variable, dependent. So these are dependents on top, my bad. So it's the second dependent variable minus the first dependent variable. All that'll be over the second independent variable minus the first independent variable. Now, y'all seen this formula written in math terms before? So we notice second dependent variable would be your second y. So that's where we get the y2 from. And the first dependent variable will be your first y value. So that's where we get the y1. So this just means the second y value minus the first y value. And the same on the bottom. The second independent variable will be the second x, which is x2, minus the first independent variable, which will be your x1. So what they'll do, they'll give you 2 points. You'll have your x1 and your y1, and you'll have your x2 and your y2. So what I'm going to do is get some graph paper and show y'all how I would actually find the slope of a line. So y'all let me see if I can draw me a graph here in the middle. All right, so that'll be my x-axis, and that'll be my y-axis. So let's see, let's just go out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm just going to make mine 10 by 10. So 10 would be one more up there. So that'd be negative 10, and then the same thing down. All right, so all these got arrows going on forever. All righty, so let me put 1 point will be right here, and then my second point will be right here. So let me draw that line for us. So let me see, this point is over 1 up 2, so this point will be 1 comma 2. So you always put your x first and then the y value. So notice I went right 1, which is the x value, and up 2, which was the y value. This point over here, we're at 5, 6, 7. So we went over 7. So the x values are 7 on that one. And then we went up 1, 2, 3, 4. So we went up 4. So that point would be 7, 4. So my line is just going to go through them points. Okay, so what I'm wanting to do is to find the slope of this line using these 2 points. So this will be x1 and y1 because they're my first x and y. This point will be my x2 and my y2. So independent variable 1, dependent variable 1. Independent variable 2, dependent variable 2. Okay, so remember my formula was the slope equals dependent variable number 2, which was my y2, minus my y1. All that'll be over my x2 point minus my x1 point. So let's fill in for the numbers that we got. So y2 was 4, so it's going to be 4 minus y1, which is 2. So on top, we got 4 minus 2. On bottom, we got 7 minus independent variable 1, which is 1. So that gives me a 4 minus 2 over 7 minus 1. So on top, 4 minus 2 is going to give me a 2. On bottom, 7 minus 1 will give me a 6. So now we've got the slope, but what we need to do to this slope is reduce to lowest form. So 2 divided by 6, if you can't reduce that, you can do it on the calculator. 2 divided by 6 is going to give you 0.333, but when you turn that back into a fraction by hitting math and enter twice, it turns it into a 1/3. So remember, when we was reducing fractions, both of these, they divided by 2. So that 2 divided by 2 gave me 1, and then 6 divided by 2 gave me 3. And then that's the only number they divide by, both of them, so that's the final form. So what that means is to go from one point to the next, I could use my slope of 1/3, which would go up 1 and over 3, and then up 1 over 3. And I could go up 1 and over 3 and still be hitting points on that line, okay? And that's all that slope is. It tells me how much does my line go up as it goes to the right, okay? So this tells me that I went up 1 unit for every 3 units that I went on that x-axis. So y'all, let's try me another one. Now notice, this line went uphill, and you see this slope is positive. Anytime you get a positive slope, your line has to go uphill left to right. And I'll write them down for you in a little bit, okay? So let me try another one of these examples. All right, so I'm just going to go out 1, 2, 3, 4. I'm going to make that a 5, -5, and I'll do that up and then down. All right, so let me let another one in. All righty, so on this one, I'm going to have 1 point right here. And then my other point will be right here. So let's see what these points are. For this point, first is the x, and my x is left 2. So I'm over here at -2. So my x value is a -2. My y value is up 1, 2, 3. So notice it's equal to 3 on the y-axis. So let's get this point. This point, you go x's first. So you went right 1, 2, 3. So the x on that one is a 3. And then we get a y value by going down. So 1, 2, 3, 4, 5. Since I went down 5, the y value is a -5. All right, y'all. So if we was to draw my line here, it's going to cut right through my points. So we want to find the slope of this. So this is my first point because it's the most left. So this will be the x1 and the y1. And this point's second, so that'll be x2 and y2. So I always go left to right on my graph, okay? So here we go. We're going to find that slope. So remember, the slope is the change in your y values or your dependent variables over the change in your x values or your independent variable. So what we're going to do now is just plug in our numbers, okay? And I wanted y'all to watch this one because first I'm going to put my y2, which was -5. minus my y1, which is a 3. That's going to be on the top. On the bottom will be my x2, which is 3, minus my x1, which is a negative 2. So what I usually do on that is put my second number in parentheses. So I remember you got that subtraction there, and then you're putting in a negative number, okay? So now watch, the calculator can do this. But really, when you see a negative 5 minus 3, that's like a negative 5 plus a negative 3. And anytime you add like signs, you keep that sign. So that's going to be a negative. And then you add the numbers together. So 5 and 3 give me 8. So that's going to equal a negative 8 on the top. Now be careful on the calculator, because this is the negative key and that's the subtraction. So you got to hit the negative key down here, negative 5, and then minus the 3, and that's going to give me my negative 8. On the bottom, we got 3 minus a negative 2. Anytime you subtract a negative, that's like 3 plus 2. Anytime we got these two negatives, we make that a plus, and then 3 plus 2 would give me a 5 on the bottom. Now, to do this one on the calculator, you got to hit the 3 subtraction key, and then do the negative key and the 2. So now it's subtracting a negative 2, which is going to make it add and make that a 5. So this slope is negative 8 over 5. Let's see if that will reduce. So we would hit negative 8 divided by 5 on the calculator, hit enter, and then turn that back into a fraction by hitting math and enter twice. And notice it kept it at a negative 8/5. So y'all, what this is telling me is to go from one point on this line to another point on this line. I would go down 8 because the y value is negative. So we would go down 8. 1, 2, 3, 4, 5, 6, 7, 8. And from that 8, since the bottom number is a positive 5, we would move right 1, 2, 3, 4, 5, and we're right on that point. So that's what the slope is telling me, to go down 8 and right 5 to get to that next point. So I like this, being able to use these points to get that slope's a nice thing in math, okay? Now notice this one. That's a negative slope. Anytime that slope is negative, your line is going to go downhill from the left to the right. Always read your graphs left to right, okay? Okay, let me find my paper. I'm going to do one more of these. So I wanted to show you the third type of slope I can have. So are y'all able to see that slope formula and work it, you think? So here's 5, and let's go negative 5. And then the same thing. All right, so this line, I'm going to put one point right here. And then my next point will be right there. So that's going to be a straight line going straight across, it looks like. So here was my X, and here was my Y. All righty, so this is my point 1. So let's see what that equals. So we go left 1, 2. So that's at negative 3. So the X value is a negative 3. The Y value is up 1, up 2. So the Y value is a 2. So this point over here, the x value, so let's see, we went 1, 2, 3, 4 to the right. So that's 4 for the x. And then we went up 1, 2. So we went up 2 for the y. So here's x1 and y1 because they're my first point. And then x2, y2 for my second point. Okay, so let's see, the slope is going to be the y2 minus the y1. So that's where to get the rise. And the x2 minus x1 is the run. So let's fill in. We got a y2 right here. That's a 2. Minus my y1 is a 2. That's going to be all over my x2, which is a 4. Minus my x1, which is a negative 3. So once again, I'm going to put that negative 3 in parentheses. All right, so let's see what we get. We get a 2 minus 2 on the top is actually a 0. And remember, 4 minus a negative 3 is like 4 plus 3. And 4 plus 3 is going to give me 7 on the bottom. So what this slope means is when you start at this point, 0 means you don't move up or down. You stay on the line and then move right 7. 1, 2, 3, 4, 5, 6, 7. Once I move right 7, I'm on that line still. Now, if you ever get a slope of 0 over 7, MATLAB will make you reduce that all the way to a 0. So a 0 slope will always be a horizontal line going across there, okay? All righty, y'all, so let me go back to my notes. So now that we got the slope down, we're going to look at what we call equations of lines. So the general equation for a linear function. So I'll do it in words and then we'll look at the algebraic equation. So in words, the dependent variable so the dependent variable equals your initial value plus parentheses your rate of change. And remember, my rate of change is also my slope times my independent variable. So that's independent variable. Now we can rearrange this side so that we get dependent variable equals my slope times my independent variable plus my initial value. So this one, they start with initial value and then they add whatever your slope times your independent variable is, which is your x. In this one, they do that first. They take your slope times your independent variable, which is your x, and then they add that initial value. So let me write this in algebraic form. And y'all, I showed y'all this the other day in support. The algebraic form of this line is going to be y equals mx plus b. So remember, b is your b-intercept. I mean your b equals your y-intercept. And guess what? Your y-intercept is your initial value. That's your initial value. That's your starting point on that y-axis. M is your slope or your rate of change. X is your independent variable. And then finally, we got y over here, and y is our dependent variable. Okay, so as long as I know for 3 of these, I can always solve for the 4th one. So if I know my y, my m, and my x, I can solve it for the b. If I know my y, my x, and my b, I can solve it for the m. If I know my m, x, and b, I can find the y value that goes with that x value, okay? All right, so let's look at what these y-intercepts are telling us. So I'm going to do another graph for us. So what I'm going to graph is y equals 2/3 x plus 3. Now, if y'all remember the other day, I showed y'all how to graph using the slope and intercept form of a line, which is what I got. So here's 5, -5, 5 on the y, that's going to be my x, and then down, -5. So remember, if I was going to graph this, that 3 is your starting point. And remember, if you write that as a point, that y-intercept is 0, 3 in point form. My slope, which is the m, is going to equal 2/3. So remember, this is my initial value, so that's where I'm going to start at on the y-axis. So we're going to go up 1, up 2, up 3. This is 3 on the y-axis, so that's where we always start that at. Now, if you don't have a number at the end, you would start at 0. That means your initial value would be 0 if there's not a number at the end, okay? Now, my slope is a +2 over a +3. So remember, 2 means that you're going to go up 2 in the y direction. And then that 3 on the bottom means you're going to go right 3 in the x direction. Remember, your dependent variable on top, which is your y's, independent variable on bottom, which is your x's. So starting from this 3, you would go up 2. So going up 1, up 2. Now don't put your point yet, because you still got to move the x's, okay? So I went up 2. From that point, I would go right 3. So 1, 2, 3. So after I move right 3, I would draw my dot for my second point. And at this point, I could now draw me a line. Okay, so up 2, right 3. Now remember what I said. If that slope is positive, this is going to go uphill left to right like we had wall go, okay? But notice, 3, which was my y-intercept, your y-intercept is always where you're going to cross that line at. So let's draw this on the calculator and see if we come up with what we got here. So turn your calculator on. So to graph, you're going to go to the very top left button that says y equals and press it. Now, it's already showing y1 equals, so I need to put in my equation for the right side of that calculator. Now, I'm going to show you 2 ways you can put this in depending on how you want to do them. So the first way, that 2/3, I can write it as 2 divided by 3. And then get my x, which is the long button right here by the green one. It's got an X and a T. Hit that, and it puts an X there. And then plus 3. That's one way you can put this in. Another way, to put the fraction part in, to hit the fraction, watch what I do. So I'm going to clear that. I'm going to hit this alpha button, and then the y equals. You see it brings up a little, so I hit alpha, y equals, and that brings you up a list. And ND means numerator denominator style, so I'm just going to hit enter for that. And look, it put a fraction there. So I can put a 2 on top, go down and put a 3 on bottom, and then I can arrow right. So I did the one that had the N over D, and then enter. Okay, now to put that up there, now I can just put my X plus 3. So on the newer calculators, if you want it to look like a fraction, hit the alpha Y, and that puts it into fraction form for you, okay? All right, so here's my graph. Let's see what we get. To graph this line, the last button on the top row says graph. Hit that. And y'all, that looks like it's crossing just like we had. It's crossing at the 3 on the y-axis. And it looks like it's crossing right here at -5 like mine did. Okay, so that's just one way that you can sort of verify your graph is doing what you were putting on that paper. Okay. All righty, so let's look at the slope a little different. Three cases of slopes we're going to look at. If the slope is positive, if that slope is positive, the graph goes uphill, left to right. Second case, that slope could be negative. If the slope is negative, it's going to go downhill, left to right. And the third case, that slope could be 0. And when I had the 0 slope wall go, it made a horizontal line. So horizontal line, left to right. Okay, so my uphill slope, my downhill slope, and my horizontal line. Oh, I hate it when my paper flips up like that. All righty, so 3 types of slope. So let me graph. So I'm going to graph 3 lines with the same y-intercept, but they're going to have a different slope. All right, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, negative 5. 1, 2, 3, 4, negative 5. So there's my X and my Y. So I'm going to show you what the slope's doing to them. So I'm going to draw 3 lines. I'm going to draw Y equals 1/2 X plus 2. I'm going to graph Y equals negative 1/2 X plus 2. And then my third one will be Y equals 0x plus 2. So I will say this, anytime the slope is 0, they could write that as this, Y equals 2. Anytime it slopes 0, because 0 times x is 0, so you can shorten this one by writing it as Y equals a number, okay? So let me graph these 3 to show you what's happening. So the first one had a positive slope. So we start at 2 on the y-axis. So up 1, up 2. So there's my y-intercept, and that's going to be the y-intercept for all 3 of them. Now, since that slope is 1/2, I go up 1 and right 2. So up 1 and right 2 puts my point right there. So I got my first line. And you can go anywhere on that line by going up 1 and over 2. Up 1 and over 2, and you'll be on that line all day long. This one had a negative 1/2 slope and a y-intercept of 2. So we're still starting here at the y-intercept of 2, but since that's a negative 1/2, we're going to go down 1 and right 2. So any negatives, you keep them with the top number, okay? So from that y-intercept, we go down 1 and then right 2. That's going to put me right here. So my second line with the negative slope is going downhill. Okay, the first one, here's my y equals 1/2 x plus 2. This is y equals negative 1/2 x plus 2. And then this one was y equals 0x. Now remember, 0x is like a 0 over 1. If you got to make it look like a fraction, you got to put a 1 under it. Okay, so start at 2, which is the same y-intercept. 0 for the y's, I don't go up or down, I stay there. And then I go right 1. So right 1 puts me right there. So there's no up or down, but we do go right 1. You have to go right at least 1, okay? So then, let's draw that line. So this one was y equaled 0x plus 2. And y'all, that's what we thought. We knew this one was a positive 1/2, so that line would go uphill. This was a negative 1/2, so that line's going to go downhill. And then this one had a 0x, which means 0 slope, so it had to be a horizontal line going straight across. All right, so the same type of thing I want to show y'all now is one more graph. So this is the fun part about graphing, is actually what? Drawing all these graphs. That's a LOL on that, right? All right, y'all, so let's go. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. Negative 5. And negative 5. So there's my X and my Y. So I guess this will be for all y'all that like doing a business class maybe. Maybe some of y'all doing social work. If you do statistics, you got to learn to graph a little bit. Okay, so on that one, I had the same y-intercept and I was changing the slope. On these ones, I'm going to have the same slope on all of them, but different y-intercepts. So this will be 1/2 x plus 3. This one will be 1/2 x minus 2. And then this one will just be y equals 1/2 x. Remember, since I don't have a number out there, it would be like a 0 on this one, okay? All right, so let's graph my first line. Starts at 3, so 1, 2, it's going to start right there at 3. That's a positive 1/2 slope. So from that 3, I would go up 1 and right 2. So first line, positive slope, is going to go uphill. And y'all, actually, all three of these better go uphill because they got the same slope, right? But this one starts at a -2, so let's go. -1, -2 is where this one starts. But it's still got a slope. It's going to be what? Up 1 and right 2. That's going to put me right there. So let's draw that line. And then finally, this is y equals 1/2 x. Remember, since there's not a number there, we treat it like a 0. So this one would start at the 0. And we also call this point in the middle the origin. Okay, 0, 0 is the origin. But from that 0, we're going to go up 1 and right 2. So that's going to put me right there. So the thing we notice about these three lines, had I drawn these perfect, these three lines would have all been what we call parallel to each other, okay? But notice, these numbers at the end change. That's just what they're starting on the y-axis at. But they all three go up 1 and over 2, up 1 over 2, up 1 over 2, up 1 over 2, I'm still on the line, up 1 over 2, I'm still on the line. Okay? So basically the slope is the slantness of those lines. All right, y'all, so last thing I'm going to look at for this is what we call creating a linear function from two data points. And I'll just call them points x1 and a y1, x2 and a y2. So they're going to give me two sets of independent variables with their dependent variables. Okay? So the first thing you got to do to come up with a linear function from two data points, first thing we got to do, we got to find the slope of the 2 points. So remember, to find the slope equals our second y minus the first y over the second x minus the first x. When we do that, we will have our slope. So then we're going to substitute for the slope. And the x and y value from either point into the equation y equals mx plus b, and we're going to solve for the b. And remember, the b is my y-intercept. So guess what? After I do that, that'll give me the y-intercept, which is the b. I'll already know the slope because I found it up there. That'll be the m. So remember, that's going to equal your m. If I know them two, then I can plug it in for the m and the b, and I'll have my equation in the form of y equals mx plus b. So substitute the m and b into the y equals mx plus b. Okay, so I'm going to do a problem doing that. Okay. Now, I will say, I'm going to give us the 2 points to use on this tonight, but sometimes if they give you a graph, you're going to have to figure out 2 points on it by looking what's on that line, okay? So I'm actually going to give us the points. So we're going to write a linear function given the 2 points. So I'm going to start with, say, a -2 and a 4. And my second point, I'm going to make this one a 6 and a, oh, how about a 8? So x1, y1, and this will be my x2, y2. So the first thing we got to do, we got to find our slope. And we know that we do the slope formula is going to be the y2 minus the y1 over the x2 minus the x1. All right, doing that, let's plug in our numbers. Y2 is an 8 minus y1 is a 4. That's going to be over the bottom, which is a 6 minus a -2. So I'm going to put my -2 in parentheses. Anytime I got a negative number that follows my subtraction, I put it in parentheses. All right, let's see what we get. 8 minus 4 is 4. 6 minus -2, remember that's like a 6 plus 2, so that'll give me 8 on the bottom. And y'all, I'm going to reduce this. 4 over 8, both divide by 4. So 4 divided by 4 gives me a 1 on top. 8 divided by 4 gives me a 2 on the bottom. So I know my slope is 1/2, which is going to be my m. So then we're going to use either one of these points. So since most people don't like negative numbers, I'm going to pick this point to keep my numbers positive. Okay. Now remember, here's our y equals mx plus b. We're going to put that in for the y, that for the x, 1/2 in for my m, and we're going to solve it for the b. So here we go. The y value is 8. That's going to equal m, which is 1/2, times my x, which is 6. And then I got plus b, which is what I'm going to solve for. Now, it'll work if you put a 4 and then your -2 here. You'd get the same answer for your b, okay? So let me show you what I would do first. Multiplying comes first. So we got to figure out what is 1/2 times 6. So the calculator will do that. 1 divided by 2 is going to give me 0.5 times 6 is going to give me 3. So 1/2 times 6 is 3 plus my B. Now, what we need to do is get the B by itself on this side and all the numbers over here for my answer. So what you got to do is add the opposite when you move stuff from side to side. So since this 3 is positive, you want to subtract that 3 from this side, which means you're going to subtract that 3 from the other side. And that goes back to what I do to one side to make something go, I got to do to the other side. But notice, 8 minus 3 on this side is a 5. 3 and negative 3 canceled out. All that's left is my B. So I now know what the B equals. The B is 5. So to write my formula, I would put Y equals, in place of the M, I would put 1/2. Then I would put my X, and then plus my B, which was 5. And that would be the linear function that I would get had I started with these 2 points. All righty, y'all. So here's my plan. I just wanted to get y'all a good little lecture on learning what that slope was and how to write these linear functions. So if you feel good, you can start the 9-2 homework now. But what I'm going to do on Thursday night, the only thing I'm doing for my lecture is I'm going to work through the 9B homework that night. So the only thing we're doing this week is 9B. And then, like I said, once we go back from Thanksgiving break, we'll take the 8 and 9 tests and we'll start studying for our final. In that first day back after Thanksgiving, we're going to review in class for the chapter 8 and 9 test, okay? So y'all's final is going to be due by December 15th, I think it is. So December 15th will be when all the finals are due online, okay? So let's stop this share.
Mr. Rutherford, I have a question.
Yeah, I got you.
This Brandon, I've submitted my report and I still hadn't gotten a grade yet. I was wondering if you had received it.
Yeah, I got a big onslaught of about 6 or 7 of them at once. So what I was doing is I'm just printing them off, and you should start seeing grades maybe sometime this weekend, if nothing else.
Okay.
I skimmed through those, and those all actually look pretty good, though. Some of y'all got some pretty far out dreams on those cars. And then some of y'all were more down to earth, I guess you would say. But remember, if you haven't turned that in, it is due by Sunday night the 22nd for sure. And Brandon and nothing else, I got Thanksgiving to play with them projects, okay?
Okay, I was still thinking it was the 15th day, so that's why I was just asking.
Oh no, I had extended it because I had a few that had trouble trying to download that file and stuff, so I had to resend them out again. So, but yeah, I've got about 9 of them now that I'm going to be reading over the break.
Good, good.
All right, let's see. Oh, I just got an email that said the finals will be the 14th and 15th for all y'all's classes, okay? So that's when they're going to be due by. So my class will be the 15th for y'all, but if you got like Monday, Wednesday classes, those finals will probably be due the 14th. All right, y'all, so let me stop this recording and I'll send